Hello dear learners, welcome to another lesson of physics. My name is Biekwa Sosemakula Samuel. I am a teacher of physics. In today's class, we are going to describe and carry out an experiment to determine mass of a meter rule using a known mass, and we are going to use the principle of moments. The principle of moments states that if a body is in equilibrium, the sum of clockwise moments about a given point is equal to the sum of anti-clockwise moments about the same point. So we are going to use that to determine the mass of this meter rule using these known masses. In this experiment, we begin by determining the position of the center of gravity of this meter rule. The center of gravity is the point on an object through which its weight acts, or through which the gravitational force acts. And when we pivot an object about its center of gravity, it balances. So to find the position of the center of gravity of this meter rule, we are going to put it on our knife edge and adjust the position until it balances horizontally. The point at which it balances horizontally is the center of gravity, and we are going to note that point. When you look at this, at 50.2 centimeter mark, at the 50.2 centimeter mark, we are going to suspend this known mass. Here we have three masses, each one is 50 grams. So the total mass plus the holder is 150 grams. We are going to suspend this at a certain distance from the 0 centimeter mark, and then we shall adjust the position of the meter rule until it balances horizontally. So we can put this at the 10 centimeter mark. We suspend it at the 10 centimeter mark. Then we move our meter rule we put the meter rule onto the knife edge, and then we start adjusting the position until we find where it balances horizontally. And we find that that position is the 30 centimeter mark. Position is the 30 centimeter mark. We have hung the known mass at the 10 centimeter mark, and this meter rule balances horizontally when the knife edge is at the 30 centimeter mark. This is a diagram representing what we have just been doing here practically. Here we have our meter rule, we have our scale from 0 to 100. We first of all determined our center of gravity, and the center of gravity was at the 50.2 centimeter mark, and we said that is the point through which the weight of the meter rule is acting. Now we suspended 150 grams at the 10 centimeter mark, and when we adjusted the position of the meter rule, it balanced horizontally when the knife edge was at the 30 centimeter mark. Now we are going to apply the principle of moments to determine the unknown mass, which is the mass of the meter rule. So the sum of the clockwise moments should equal the sum of the anti-clockwise moment. The weight of the meter rule has a clockwise moment about the pivot, while the known mass has an anti-clockwise moment about the pivot. The moment is the product of the force and the perpendicular distance of the line of action of the force from the turning point. So we are going to have the mass of the meter rule times G, which now becomes the weight, times the perpendicular distance of the line of action of the weight from the turning point, which is Y. This should equal to the weight of the known masses, which will be 150 over 1000 G, where G now is acceleration due to gravity. We are trying to get the weight, times the perpendicular distance of the line of action of this weight from the pivot, which is X. So of course the G's will cancel on both sides. We can find the values of Y and X. Now we are going to use these values of X and Y to get the value of M. M is the unknown mass of the meter rule. So from this expression, we'll see that M is actually equal to 150 over 1000 times X over Y. So we are going to have 150 over 1000 times the value of X is 20 divided by 20.2. Therefore, is equal to, so M equals 148.5 over 1000 kilograms, which we can write as 148.5 grams. 148.5 grams. Therefore, the mass of this meter rule has been found to be 148.5 grams using the principle of moments and using that known mass.